Hi there, in this video we are going to discuss all the formulas and concepts related to triangle, and this will be a quick revision for all the concepts and formulas. So let's understand concept number 1 of triangle. So concept number 1 is what is the sum of interior angles of a triangle. So sum of the interior angle of triangle is always 180 degree. First, we need to understand what is interior angle. So just make sure that interior angles refers to two inner angles that form where the two sides of a polygon come together. So interior angle can be anything in any polygon where like two sides, the angle they form inside, that angle is known as interior angle. So in case of triangle, so sum of the interior angle is always 180 degree. So concept number 2 is what is an exterior angle of a triangle. Just understand what is an exterior angle. So exterior angle of a triangle is what? An exterior angle of a triangle is formed by any side of a triangle and the extension of its adjacent side. Means we are extending one side of a triangle and the angle is forming between the extended side and the adjacent side. That outside angle is known as exterior angle of a triangle. Concept 3. What is the relation between the exterior angle and the interior angles of the triangles? So always just understand an exterior angle of a triangle is always equals to sum of the two non-adjacent or opposite interior angles of a triangle. So suppose that one exterior angle, the value of one exterior angle is always equals to sum of the two non-adjacent triangles. So if this angle, like angle x, y and z, interior angles are there in this triangle, and outside angle is angle p, which is an exterior angle. So value of angle p will always be equal to angle x plus angle y. So value of exterior angle will be always equals to sum of the two remote interior angle. Now concept 4, what is the value of exterior angle in an equilateral triangle? So value of exterior angle in equilateral triangle is always 360 divided by n. N is number of sides, and so in equilateral triangle 3 sides are there. So the value of exterior angle in equilateral triangle will be 120 degree. Again, understand this formula is applicable for all regular polygons. So this property is applicable for either square or regular pentagon or hexagon or any other regular polygon where we can say 360 divided by number of sides. So we can find out the value of exterior angle of any regular polygon. Concept number 5, perimeter of equilateral triangle. So perimeter of equilateral triangle is n into s. N is number of sides and s is length of the side. So whatever side is given, so we can multiply by simple number of sides, so we can find out the easily perimeter of a equilateral triangle. Again, this concept is applicable for all the regular polygons. So it is either a square or a regular pentagon or hexagon or heptagon. So now let's move to the concept number 6. Concept number 6 is what is the angle of a triangle? So general term, if we want to know that what is an angle of a triangle, so angle basically, like always, it's a very interesting that angle always corresponding to their opposite side. So let's say in this figure, like in this triangle ABC, if side ABC is there, so the angle opposite to that side, so angle opposite to the side AB is angle X. So if we want to know what is the angle of a side AB, so angle of side AB will be angle X. So as angle of side AC will be angle Z, and angle of side BC will be angle Y. So always remember that the angle of the triangle is always opposite of that side. So side AB is here, so opposite of that side is angle X. So we can say the angle of side AB will be angle X. So this is very small concept but very important. Most of the time we may get confused. Now concept number 7, So what is concept number 7? What is the sum of any two sides? So sum of any two sides, like sum of any two side in the triangle is not always greater than the third side. So if we can say, we can see in this triangle ABC, so sum of any two side, either you can take AB or BC. So if we'll take any two side, so sum of any two side will be always be greater than the third side. So here we can say AB plus BC has to be greater than the AC. So any two side we can take either AC and CB, or any two side we can take it. Concept number 8 is what? Again, difference between any two side. So again, interestingly, the difference between any two side is always lesser than the third side. So if we find out the, let's say, side AB and BC, if I'll take the difference of these two sides, so it will be always less than the third side. So concept number 9 is what? The side of a triangle. If you are given two sides of a triangle, so then the length of the third side must lie between the difference and the sum of two given sides. It is always. Concept number 10, very interestingly, the again feature of the triangle, feature of the side of a triangle, the higher the angle, longer the side. If your angle is higher, so side will be longer. So suppose that length of AB is what, 10 centimeter, so angle is what, let's say 60 degree. So another side, if the side is shorter, so angle will be lesser. So we can say another word, higher the angle, longer the side. Very important concept, small concept, but it is applicable for all the concepts where we need application in the when we solve the questions. So we need applications. So this application is always like we have to keep in our mind, higher the angle, longer the side. So concept number 11, height of a triangle. So what is the height of a triangle? So perpendicular distance between the base and the vertex opposite to it. So base and the opposite vertex. So that is the height of a triangle. So it's the height of a not only a triangle, but any figure we can always find out the base and the perpendicular distance to the vertex, opposite vertex. So that is the height of a triangle. So how we calculate height at our home? Like we stand and then we straight. We stand straight. So the height is what always calculate. The base is what your floor, and when you are standing, so you are having a perpendicular distance. So that distance is what your height. Always be straight when we take the height. So, and not necessarily that height in case of triangle or any other figure, we can always calculate from the inside. So when we are solving the application questions, so height can be calculated from the outside of the figure also. We can extend the line and we can calculate the height. Now concept number 12, property of vertex of triangle. So important thing is what, that all three vertex cannot be in straight line. So it is important, like if all three vertex are straight line, so definitely it won't be a triangle. So the only property they ask from the what is the property of vertex. So if all three vertex are in the same line, so it is not a triangle, that is the imaginary triangle we can say. So the triangle won't exist if all three vertex are in the same line or a straight line. So concept number 13, acute angle triangle. So in a triangle, if all three angles are acute, so we can say that this triangle is known as acute angle triangle. Or we can establish the relation also that a square plus b square is always greater than the c square. Like, so if sum of the squares of the any two side will always be greater than the square of third side. So all three angles will be what, less than 90 degrees. So that triangle is known as acute angle triangle. Now concept number 14, so the obtuse angle triangle. So if one of the side is more than 90 degree, so we can say that triangle is known as obtuse angle. So obviously, like only one side can be a more than 90 degree, two side cannot be more than 90 degree. So what will be the value of third side then? So if only one side, if in a triangle, if only one side is more than 90 degree, so obviously the other two side will be the less than 90 degree. So if only one side in a triangle is more than 90 degree, so that triangle is known as obtuse angle triangle, or we can say in the triangle a square plus b square is always less than the c square. Concept number 15, scalene triangle. So scalene triangle is what? A triangle that has all its sides of a different lengths. It means all the sides of a scalene triangle are unequal and all three angles are also of a different measure. So meaning that the value of all three sides will be unequal and the value of all three angles will be unequal. So that kind of the triangle is known as scalene triangle. Concept 16, Pythagoras theorem. So the Pythagoras theorem basically states that the in right angle triangle, the square of the hypotenuse, which is the longest side, is always equals to sum of the square of other two sides, that is base and perpendicular. So if we can see in the right angle triangle, so the where 90 degree angle is formed, so opposite to that 90 degree, that side is known as hypotenuse and other two sides are known as perpendicular and base. You can flip these two sides. But remember, one very important thing is what? The hypotenuse is always a longest side in a right angle triangle. So opposite 90 degree, that is hypotenuse, is the longest side. So Pythagoras theorem is what? Always hypotenuse square is equal to perpendicular square plus base square. Now concept number 17, triplets. So what are the triplets basically? So when combination of three sides, when they satisfy the Pythagoras theorem, so these three sides are known as triplets. So generally, when we are appearing in the examination, so always it is always easy for us to remember and learn, before we appear in the examination, if we have ready all the triplets less than 100, if we can mug them up. So the list is given here on the screen. You can see that these are the triplets where you should always remember. So you can easily click the things the moment you see the figure, so it will easily click in your mind and we can save a lot of time to solve the questions. So some famous triplets are 3, 4 and 5. How it is a triplet? Because 5 square is what? 25. 25 is equals to what? 4 square is 16 plus 9 square is what? 3 square is what? 9. So 25 is equals to 16 plus 9. So which is 25 is equals to 25. Similarly, if you can see the 5, 12 and 13, 8, 15, 17. So you take the longest side square and you take other two sides square, rest two sides, and take sum of rest two sides. So that will always equals to the sum of the square of the, that will always equals to basically square of the longest side. So these are the triplets. Triplets are very important. You should always mug them up. Triplets at least till 100. Concept number 18. Concept number 18 is what? There are some specific right angle triangle. So two are very important. So in that, first is what? 90, 45, 45 triangle, or we can say right angle triangle. So why it is important? Because first of all, it's an isosceles triangle, and second is what? The ratios of the sides is very important. So if 90 degree is here, so opposite to that will be what? The side, if you will take in the ratio 90, 45, 45. So ratio always comes root 2 is to 1 is to 1. As we know that hypotenuse is the longest side, so here root 2 is the highest value. So root 2 will be the hypotenuse and other two side will be perpendicular and base. So remember 90, 45, 45. So in 90, 45, 45 triangle is a right angle triangle whose sides are in the proportion of root 2 is to 1 is to 1. Concept 19, which says another specific right angle triangle, which is 90, 60, 30. So 90 60 30, again it's a right angle triangle, and in this right angle triangle, so the ratio of the side is what, 2 is to root 3 is to 1. 2 is the highest side, so which we can say the longest side is what, hypotenuse. So 2 is what, hypotenuse, and other two side will be perpendicular and base. So we can always prove, if you will get confused, so always like use the Pythagoras. So use the Pythagoras theorem, and then you can easily get the ratio right. So 2 square is equal to what, 4, is equals to root 3 square is what, 3, plus 1 square is what, 1. So we are getting left hand side is equal to right hand side, 4 is equal to 4. So remember, 90 60 30 triangle, specific right angle triangle where the ratio of the sides will be 2 is to root 3 is to 1. Concept 20. So there is a property of right angle triangle. What is the property? That circumradius of right angle triangle is what, always half of the hypotenuse. So as you can see in the figure, that this is the right angle triangle, and the outer circle is what, circumcircle, and the from point you can see the C to that angle, like vertex of the triangle where 90 degrees form, that is what, circumradius. So or circumradii, either you can say circumradius or circumradii. So circumradii is equals to half of the hypotenuse of right angle triangle. So this is again important property. Circumradius is what, half into hypotenuse. Now let's come to the concept number 21. So here we are starting now area of triangle. So there are various way we can find out the area of triangle, but we need to see the what are the situations and what are the datas are given. So one very common formula which we I think everyone knows, that area of triangle is what, half into base into height. This formula is applicable to all the triangles. Like this formula you can use in any of the triangle, but only thing is that the two things are very important, two ingredients are important, height and base. If height and base is given, both the things are given, then definitely we can use the formula, and then we can find out the area of triangle. So area of triangle is what, half into base into height. Height is what, again I want to reiterate, what is the height of a triangle? Height is what, basically perpendicular distance from vertex to the base, that is height. Height can be inside in the triangle or it can be outside from the triangle. Concept 22. Area of the triangle when three sides are given, or that formula is also known as Heron's formula. So when the height is not given, but the measurement of three sides are given. So if you see in the triangle ABC, where the length of AB and BC and CA is given, so how we are going to find out? So there is a formula. The area is what? So area is what, root of S into S minus A, S minus B, S minus C. What is S here? S is what? Semi-perimeter. Semi-perimeter is what? Will take sum of all three sides and divide by 2. So S, the value of S will be what here? A plus B plus C by 2. Here you can see that A, B, C are the sides. So Heron's formula is important when all three sides are given. So simply we can plug the values, we can find out the semi-perimeter by adding all three sides divide by 2, and then we can plug in the formula. Remember the formula is what? Square root of or you can see the formula here on the screen, root of S into S minus A, S minus B, S minus C, where S again it's a semi-perimeter and A, B, C are the sides. Concept number 23, area of triangle when in radius is given. So when in radius is given, so how to find out the area of triangle? So area of triangle formula is what? A is equals to R into S, where R is equals to what? In radius, and S is equals to semi-perimeter. Here we just quickly revise what is in radius and in circle. So in circle is what? Basically when we draw a circle within the within the triangle, and this circle basically touches each side of a triangle only once. So that circle is known as in circle, and radius of that in circle is known as in radius. So if in radius is given and semi-perimeter is given, what is semi-perimeter? Half of perimeter. So if three sides are A, B, C, so semi-perimeter will be what? Half of A plus B plus C. So if semi-perimeter or all three sides are given and in radius is given, so we can easily find out the area of triangle by using the formula area of triangle when in radius is given will be what? A is equals to R into S. Concept number 24, area of triangle when circumradius is given. So when circumradius is given, so the area of triangle will be what? ABC upon 4R. So ABC are three sides of the triangle and R is what? Circumradius. So we can vice versa also. We can use this formula like how to find out the circumradius. So we can also say that ABC upon 4A. So if area and all three sides are given, so we can find out the circumradius also. So similarly that we can find out either circumradius or area if we have all three sides, or area is given or circumradius is given. So whatever thing is being asked, like either they are asking circumradius or area, so we can easily find out. So what is circumradius? So for circumradius is what? Basically the radius of a circumcircle. Or what is circumcircle? Circumcircle of a triangle is what? That is a circle that passes through all vertices of a triangle. So if, as you can see in the diagram, like in a diagram there is a triangle and there is a circle which is passing through all the vertices of the triangle. So that circle is known as circumcircle. So and that radius is known as circumradius. So if we want to know the if area of triangle we need to find out, generally in the triangle generally they will give you circumradius and they will give you all three sides and they will ask us to find out the area. So now we have learned the formula. The formula is what? A is equals to ABC upon 4R, where ABC are three sides and R is what? Circumradius. Concept number 25, area of triangle when one angle and two sides are given. So here as you can see in the diagram, here like two sides are given 3 centimeter and 4 centimeter and one angle is given which is 145 degree. So how to find out the area of triangle when two sides and one angle is given? So the formula is what? That half of AB sine C. A and B are the two sides and sine C is what? Angle between the two sides which are given. So here 3 and 4 are given. So the angle between 3 and 4, the two sides, the value of two sides are given, so, or we can say AB as per the formula. So the angle which is the intersecting point of these two lines, that vertex angle is what? Angle C here. So we can use the formula half AB sine C. So that way we can find out if two sides and one angle is given, so we can easily find out the area of triangle. Concept number 26, area of right angle triangle. So area of right angle triangle is what? Half product of perpendicular sides. So if as you can see in the diagram, that if this is a right angle triangle is what? Where one side is 90 degree. So if we'll multiply the product of two perpendicular sides, so and multiply by half, so we can easily find out the area of right angle triangle. Concept number 27, isosceles triangle. So what is an isosceles triangle? So an isosceles triangle is one in which the length of two sides are equal, and also in an isosceles triangle two angles opposite equal sides are equal in size. So simple concept, like in isosceles triangle two sides are equal and two angles are equal, but remember, right, those two sides are equal, they're opposite sides of the angle. Like generally we have already discussed this thing, that what is the angle of the triangle. So if we can see that here, we can see in this diagram, so if triangle ABC is there, so the angle C will be the opposite of AB. So AB and AC are two equal sides, so we can say that the opposite of AB and AC will be the equal in measurement. The angles opposite in equal side will be equal in measurement, so that is known as isosceles triangle. Okay, so but again a small concept is what is the base of isosceles triangle? So the unequal side is also known as base of isosceles triangle. So sometimes they can ask you in the question, so they will give you base of isosceles triangle is this much. So if we know the base is what? Base, unequal side is known as base of isosceles triangle. Concept number 28, area of isosceles triangle. So if base and equal sides are given, so we have a direct formula to find out the area of isosceles triangle, which is b by 4 multiplied by root of 4a square minus b square, where b is the base, or we can say unequal side, and a is what? two equal sides, right? So the formula will be what? B upon 4 in the bracket root of 4a square minus b square. So if we have value of equal side and base which is unequal side, if these two values are given, so we can simply plug in the formula and we can easily find out the area of isosceles triangle. Concept number 29, vertical angle of isosceles triangle. As we have learned what is the base of isosceles triangle, so here again a very small concept but important, that what is the vertical angle of isosceles triangle. So what is the vertical angle? So the angle where two equal sides meets. So where two equal sides they are meeting, that point, that angle is known as vertical angle of isosceles triangle. So as we know that isosceles triangle is what, where two sides are equal and opposite of equal sides, their angle opposite to the equal side will also be equal. So what will be the vertical angle? Angle is what, where both the sides they are meeting, that angle is known as vertical angle of isosceles triangle. Or basically isosceles vertical angle will be definitely the because two angles will be equal, so the unequal angle is also known as vertical angle of isosceles triangle. So here we can see in the isosceles triangle where two sides 5 centimeter 5 centimeter are given, which are the equal side, and another unequal side is what, 6 centimeter, which we also known as base of isosceles triangle. So here opposite to 5 centimeter is what, angle y, and opposite to again another 5 centimeter is what, angle z. So angle y will be equals to angle z because these two are basically equal angles, but angle x is what, unequal angle, which is known as vertical angle of isosceles triangle. So here in this diagram, so angle x is what, vertical angle of isosceles triangle. Concept number 30, equilateral triangle and its area. So first of all, let's understand what is an equilateral triangle. So equilateral triangle is what, the triangle where all three sides have same length, that triangle is known as equilateral triangle. So but obvious, like when all three sides will have the same length, so the all three angles will be the same. So here we can say the equilateral triangle in the diagram ABC, where all three sides are same, so the angle will also be the same. But important thing is what, there is a direct formula, because if one side is given, so we can directly find out the area of equilateral triangle. So formula is what, root 3 by 4 square of side, or we can say root 3 by 4 a square. A is what, equal side. Concept number 31, value of exterior angle in equilateral triangle. So value of exterior angle of equilateral triangle will be what, 120 degree, right? We have learned the formula that value of exterior angle in equilateral triangle is what, 360 divided by n, where n is what, number of sides. This formula 360 divided by n is a universal formula for all regular polygons. If we want to know the exterior angle of any regular polygon, so we can simply put in the formula 360 divided by n. N is what, number of sides. So either a regular polygon is square, hexagon, decagon, regular hexagon, regular decagon, or regular pentagon. So we can easily use this formula and we can easily find out 360 divided by n. Concept number 32, height of equilateral triangle. So what is the height of equilateral triangle? So height is what, root 3a by 2. How we can find out this height? Because as we can see in the diagram, that figure ABC is a triangle, an equilateral triangle, where all three sides are equal, a. So but if we'll take height, AD is what, AD shows the height of the height in that equilateral triangle. So the property of the height is what, because height is dividing the opposite side in two equal parts and two equal angles. So since angle D will be 90 degree and angle A will be divided into two equal parts, which will be because interior angle is what, 60 degrees, so it will divide into equal part, that will be 30. So here again we can see there will be 90, 60 and 30 degree specific right angle triangle will form. So we know the ratio of 90, 60 and 30. The ratio of the side is what, 2 is to root 3 is to 1. So if we can apply that ratio, so also by using that ratio also we can find out the relation between the height and the size. So height is what? Root 3a by 2. Concept number 33, in radius and circumradius of equilateral triangle. So as we know that what are the in radius and what is the circumradius, but here in this concept we'll try to establish the relation between the side and in radius and circumradius. So in radius is what? Basically that when we draw a circle, right? So circle basically within a triangle that touches each side of the triangle in one place. That circle is what known as incircle, and radius of that circle is known as incircle. So in radius of equilateral triangle is always a by 2 root 3. A is what? Side of equilateral triangle, and divide by 2 root 3. So if you want to know the circumradius of equilateral triangle, which is a upon root 3. What is circumradius? So circumradius is what? Radius of circumcircle. What is circumcircle? Circumcircle of triangle is what? That basically passes through all the vertices. A circle which is passes through all the vertices of triangle, that circle is known as circumcircle, and the radius of that circle is known as circumradius. So circumradius of equilateral triangle is what? A divided by root 3. Here also you can see both the diagrams, which you can get a clear picture that this diagram, one diagram is what? In radius, another diagram is what? Circumradius. And in radius is what? The relation between the in radius and side is what? In radius is equals to side divided by 2 root 3, and circumradius is what? Side divided by root 3. Concept number 34, covariance and coincide property of equilateral triangles. So we know that what is interesting thing in equilateral triangle, if we draw like height or altitude, median and angle bisector, basically they all three will be in equal length. So this is called covariance of equilateral triangle, where all three covariance, so three kinds of covariances coincide and are equal for equilateral triangles. So all three is basically covariance, like the draw line which we are drawing from vertex to the base, that line is known as covariance. So that covariance, all three covariance, altitude, median and angle bisector, they all have equal length. So this is one of the very important property of equilateral triangle. Similarly, another interesting property of equilateral triangle is what? Coincide property. So as we have seen that covariance like lines, so similarly the all 4 points, circumcenter, incenter, centroid and orthocenter, they are like all the 4 points will be the all 4 basically center will be at the same place in equilateral triangle. So these all basically centers always coincide in equilateral triangle. Next concept is what? Concept number 35, which talks about the maximum area property of equilateral triangle. So if any given perimeter is given, right? So we can form various triangle. Let's say perimeter 10 is given. So we can form various triangle, like we can use ABC, like 3 side in a different combination. But important thing is what? When we form equilateral triangles, so that triangle will have the maximum area. So that is the property of equilateral triangle, that maximum area property, that property is known as maximum area property. So among all the triangles that can be formed with a given perimeter, the equilateral triangle will have the maximum area. So that property is known as maximum area property of equilateral triangle within a given perimeter. Concept number 36, equilateral triangle property in a circle. So equilateral triangle in a circle will have the maximum area compared to other triangle inside the same circle. So again, in a circle, if we'll draw various triangles, so again equilateral triangle will have the maximum area. So this is again very interesting and unique property of equilateral triangle, which we can say maximum area property in the circle. So in a circle, if we can make various or n numbers of triangles, but when we draw equilateral triangle, that triangle will have the maximum area. So that property is known as maximum, basically area property of equilateral triangle within a circle. Concept number 37, median. So what is a median? So median is a line, is a basically it's a line segment joining a vertex to a midpoint of opposite side. Okay, and it is basically bisecting it bisect the opposite side. So simple language is what, like in a triangle, like you can see that in a triangle ABC, where the line AE is drawn, that line is median, right? So basically this line is dividing the opposite side in two equal part. It is not necessary that the point E will form a right angle triangle or any specific triangle. The triangle or whatever angle is forming at E, it is irrelevant in terms of median. Only important thing is what, that this line AE should divide the opposite side, which is CB, where you can see in the diagram, which must divide the line in the two equal part or bisect the line. So here we can say, so what is a median? Median of a triangle is a line segment joining a vertex to the midpoint of opposite sides, and median always divides the opposite sides in two equal parts. Now next concept is what, concept number 38, which we can say equal area division. So as we can see in the diagram that we have ABC, triangle ABC, where AE is the median, CD is a median, and DF is a median. So interestingly, median divides the triangle in two equal parts. So if we are drawing, like in a triangle ABC, if we are drawing AE as a median, so the AE will divide the triangle in two equal part, which will be the, so triangle, we can see that there will be two triangles, triangle ACE and triangle AEB. So, but important thing is what, this, because this A is a median, so median is dividing the triangle in two equal parts. So the triangle which two triangles formed, ACE and AEB, which will be the equal in area. Concept number 39, median and right angle triangle property. So in a right angle triangle, when will basically from the right angle triangle, the vertex of right angle triangle, if we'll draw a median to the hypotenuse, right? So that median, median is what, basically the interesting property is what, median is what, half of hypotenuse. So we can say that in right angle triangle, the length of the median drawn to hypotenuse is equals to half the hypotenuse. So m is equals to, m is what denoting median, m is equal to h by 2, h is what, hypotenuse. So it is very important that m is equals to h by 2, median is half of hypotenuse in right angle triangle. And median is also circumradius of the right angle triangle. Concept number 40, a special property of median. As you can see in the diagram, like a triangle ABC, and we have three medians, AE, CD and BF. So one interesting property of median is what, if we'll take the square of all three sides, and if we'll do the 3 times of square of all three sides, and if we'll take the square of all three medians and will multiply by 4, so 4 times square of sum of all medians, and basically 3 times square of all three sides will always come equals. So here you can see in the diagram, 3ab square plus bc square plus ac square will always equals to 4 into cd square plus bf square plus ae square. So it is one interesting and unique property of a median. Concept number 41, median theorem, or also known as Apollonius theorem. So basically Apollonius theorem is what, like you can see in the triangle ABC. So interesting property again, a unique property of median is what, which is also known as Apollonius theorem, that in triangle ABC, if we'll take the square sum of the square of two sides, so here if we'll take AC square plus AB square, which will come two times sum of the median square and half of the other side. So you can say AC square plus AB square will come 2 into CE square plus AE square. So what is Apollonius theorem? Apollonius theorem is a theorem relating the length of a median of a triangle to the length of its sides. It states that the sum of the, so what is Apollonius theorem? Basically the sum of the squares of any two sides of any triangle equal twice the square on half the third side together with twice the square on the median bisecting the side. So you can easily understand from the diagram that AC square plus AB square will be equals to 2CE square plus AE square. That theorem is also that theorem is known as median theorem or Apollonius theorem. Concept number 42, centroid. So what is centroid? Centroid of a triangle is the point of intersecting of its median. So where we can see that like all three medians are there. So the point where all three medians are meeting, that point is known as centroid. Concept number 43, property of centroid. Centroid divides the each medians in 2:1 ratio from the vertex. Here you can see in the diagram, ABC is a triangle where let's say AL is a median. So this and point P is what a centroid, because the BM and CN are also medians. So the point of intersecting of all three median is known as centroid. So point P is a centroid. So the important property of centroid is what? Basically centroid divides the median in 2:1 ratio from the vertex. So here we can say that in median AL, if P is centroid, so the ratio of AP is to PL will be 2:1. Similarly, the ratio of CP is to PN will be 2:1, and again the ratio of PB and ratio of PM, again it will be 2:1. So we can say that centroid, it is again important property for most of the question. We can the centroid question they ask from this concept, because if we know the concept handy, so we can easily solve the question. So always remember that median divides the centroid in 2:1 from the vertex. Don't forget from the vertex, because the part of vertex to the median, that is double the part from the base of other side to the centroid. So that is 2:1 ratio. Concept number 44, orthocenter. So what is the orthocenter? Orthocenter is the point where all three altitudes of triangle intersects. So when we know that what is the altitude of a triangle, so perpendicular distance from vertex to the base, right? So we can form three altitudes in a triangle. So the point of intersecting where all three points, when we are drawing, let's say as you can see in the diagram, that ABC is a triangle where we are forming three altitudes. So point where all three altitudes are meeting, that point is known as orthocenter. Concept number 45, property of orthocenter. It is not necessary that orthocenter will always inside in the triangle. It can be outside in the triangle, or it can be like at the vertex of a triangle, but situations are different. If triangle is acute, so definitely the orthocenter will always lies inside the triangle. As we know that what is the acute triangle? Well, all three angles in a triangle are less than 90 degree. That triangle is known as acute triangle. And if triangle is obtuse, obtuse triangle is what? If any one of the angle in a triangle is more than 90 degree, that triangle is known as obtuse triangle. So if again it is important that when triangle is obtuse, so definitely the orthocenter will lies outside the triangle. It won't be inside, it will be outside in the triangle, as you can see in the diagram. If orthocenter of a or the orthocenter of a right angle triangle lies on the vertex of right angle. So where the in the right angle triangle, where the right angle is formed, that point, that vertex, that point is also known as orthocenter of that triangle. So we have three conditions in orthocenter. It can be lies on inside, outside, on or on vertex of triangle. Concept number 46, similarity of triangle. So when can we say that triangles are similar? So two triangles are said to be similar if their corresponding angles are congruent and the corresponding sides are in proportions. Or there is a, like, we can define, there is a criteria, there is a basically similarity criteria. So there are the three criteria. If any of three condition is meeting, then we can say triangles are similar. So the first criteria is what? AA criteria, or we can say triple A criteria. So if two pairs of corresponding angles are equal, in that case we can say two triangles are similar. So obviously, like, when two angles are similar, so third angle will also be equal. So we can, so for easily to understand, we can say it is A property, triple A property. If all three angles are equal, then triangle is said to be similar triangle. Next property is what? SSS property. If the all three sides are equal, in that case also we can say triangles are similar. And there is another third one, which is SAS property. If uh, if any two sides or one angle is equal, then that triangle is known as, again, that will be the fulfill the criteria of similarity of triangle. So we can say that SAS is what? Two pairs of corresponding sides are proportions and the corresponding angles between them are equal. So angle is between them is equal, that criteria is fulfilling, that also we can say triangle are similar. So quickly, just always remember AAA, SSS and SAS. So if any of, like, these three condition meets, so we can say that triangles are similar. Concept number 47, properties of similar triangle, or we can say side area relation. So again, when like, once we have proved that triangles are similar by testing either SSS, AA or SAS, so any of the criteria is fulfilling and we have proved that triangles are similar. So interestingly, the ratio of areas in similar triangle will be equals to ratio of square of corresponding sides. So here we can see in the diagram, if in triangle ABC and triangle DEF is there, so the area of triangle DEF and the divide by area of triangle ABC, or we can say the ratio of both areas will always equals to area, the basically ratio of the square of corresponding sides. So we can say area of triangle DEF is to area of triangle ABC will always equals to DE square divided by AB square, or DF square divided by AC square, or EF square divided by BC square. So area of ratio of area will always equals to ratio of squares of corresponding sides if triangles are similar. Concept number 48, again interesting concept, one of the unique property of similar triangles. So when, like, once we prove that two triangles are similar, so their always ratio of side will always be equals to ratio of medians, will always be equal to ratio of heights, will always be equals to ratio of circumradii, will always be equal to ratio of inradii, and will also equals to ratio of angle bisectors. So this is again unique property. When two triangles are similar, so their ratio of sides or medians or heights or circumradius or ratio of inradii or ratio of angle bisector will be equal. Concept number 49, similarity of triangle in right angle triangle. So that also known as RHS similarity test. Right. So right angle triangle similarity test. So what is the important thing in the right angle triangle? If the ratio of the hypotenuse and one side of right angle triangle is equals to ratio of hypotenuse and the one side of another right angle triangle, then the two triangles are similar. So if ratio of hypotenuse and one side is equals to ratio of hypotenuse and other angles corresponding side if equal, then we can say that two right angles are similar. Concept number 50, similarity of triangle again when altitude is drawn from the vertex. So in a right angle triangle, when altitude drawn from vertex, in right angle triangle the altitude drawn from the vertex where there is a right angle to the hypotenuse. So basically it divides the given triangle into two similar triangles and each is in turn similar to the original triangle. So here we can see, we can better understand from this diagram that if this triangle ABC is a right angle triangle where right angle is what, at angle at the vertex A. So if we'll draw a altitude from vertex A, so the altitude is what, AD. So this basically when we are drawing AD altitude, so this is dividing into two triangles, and these two triangles, not only these two triangles, that these two triangles and the original triangle, so we can say the triangle ABD, ADC and ABC will be similar. So all three triangles will be similar. So we can understand that altitude drawn from the vertex in a right angle triangle, the altitude drawn from the vertex where there is a right angle to the hypotenuse divides the given triangle into two similar triangles, each of which is turned to the similar to the original. So not only this, we are making two similar triangles, but these two triangles will be similar to the original triangle. So we are getting three similar triangles. So also when we are doing this operation, so we can write down the relationship between the sides in these three triangles. So one important relationship that emerge out in this exercise is what, AD square is equals to BD into DC. So the altitude which we are drawing, which will be the, if we'll do the square of that, will be equals to the multiply of the basically two parts of the opposite side. So AD square will be equals to BD into DC. Concept 51, angular bisector theorem. So in a triangle, the internal bisector of an angle bisects the opposite side in the ratio of other two sides. In, you can see in the diagram, like in the triangle ABC, if AD is the angular bisector of angle A, then BD divided by DC will be always equals to AB upon AC. So here you can understand this is a very simple concept which is talking about the, like, triangle ABC is given and you are doing any bisector of, you are taking any angle bisector, right? So here we are taking the bisector of angle A, which is dividing the angle A in two equal parts. So when it is dividing in two equal parts and it is touching the opposite side at D, so the relation which we are going to see, the ratio of the other two side AB and AC will be equals to the line which is the touching at D. So that two segment ratio of these two segment will be equal. So we can say always BD upon DC is equals to AB upon AC. Concept number 52, external angle bisector theorem. So the external angle bisector of an angle of a triangle divides the opposite side externally in the ratio of the side containing the angle. So here we can see in the diagram, let's say in the triangle ABC, and we are basically taking we are extending side A and making an external angle of at vertex A. So when you are forming the external angle and then we are bisecting that external angle, so that line which is going from A to D, that is the external bisector. So now theorem says that the external bisector of an angle of a triangle divides the opposite side externally in the ratio of sides containing the angle. So here we can say BD upon DC is equals to BA upon AC. Concept 53, X center. A point where the bisector of one interior angle and bisectors of two exterior angle bisectors of the opposite side of triangle intersect is called the eccentre of the triangle. So here you can see in the diagram where we have triangle ABC, and uh, at vertex A, that we are dividing the angle in two parts. So we are doing angle bisector. So here this point is what? Interior angle bisector. So when we are extending outside the triangle, and we can also see that at the point B and C also we are forming the external angles. So when we are extending external angles, these two external angles and the interior angle bisector from point A, so where all three points, all three basically these exterior angle and one interior angle meet, that point is known as eccentre. So what is eccentre? Eccentre is a point where the bisector of one interior angle and bisectors of two external angle, bisectors of the opposite side of the triangle intersect is called the eccentre of the circle. So you can see in the diagram as well that where the all three are meeting, that point is eccentre. So the circle which we are forming, that circle is known as x circle, and the radius of that circle is known as x radius. 54. A line parallel to one side of a triangle. A line parallel to one side of a triangle divides the other two sides in the same proportions. Here you can see in the diagram where we have xyz is a triangle and yz is one side, and if we'll draw KL which is parallel to yz, so this line V is going to divide the other two sides in the same proportion. So here we can say that xk divided by yk will be equals to xl divided by zl. So it is again important theorem that a line parallel to one side of a triangle divides the other two sides in the same proportion. Concept 55. Triangles on the same base. Two triangles on the same base or equal bases and between the same parallels are equal in areas. So here you can see that there are two triangles, triangle ABC and triangle PBC. So their base is same. Their base is what? BC, and their vertex A and P are on the same parallel line. So theorem says that the triangle ABC and triangle PBC, their area will be equal. So we can say always two triangles on the same base or equal bases and between the same parallels are equal in area. Concept number in center. So circumcenter is what? Basically the three perpendicular bisectors of sides of triangle meet at a point called circumcenter of the triangle, and the distance from the circumcenter to each of vertices is called circumradius, and circle drawn with the circumcenter called circumcircle. So here very important thing is what? The three perpendicular bisector of the sides. So here what we are doing, we are taking the triangle ABC is there. So what we are taking, we are taking the bisector of side AB, side AC and side BC. So where all three perpendicular bisectors they are meeting, that point is known as circumcircle, and the circle which we are forming, that circle is known as circumcircle, and radius in that will be known as circumradii. Next is what? Incenter. Incenter is what? The internal bisector of the three angles of triangle meet at a point called incenter of a triangle. The perpendicular drawn from the incenter to the three sides are equal in length, and length is called in radius, and the circle drawn with incenter called incircle. So here we can say that triangle ABC is there, and what we are taking here, we are taking angle bisector. So we are taking angle bisector of point A, angle bisector of B, and angle bisector of C, where all three angle bisector they are meeting. That point is known as incircle, and that point is known as incenter, and the circle we are going to form from that point, that circle is known as incircle, and the radius is known as in radius. So the very marginal difference between the how to draw the circumcenter and the incenter. So in circumcenter we are going to take the perpendicular bisectors of the sides, and in circle what we are taking the perpendicular bisector of the angles. So this is the difference between circumcenter and incenter. So in our geometry video series, in this video we have covered all the formulas and concepts related to triangle, and I'm sure this will be a quick revision for all the concepts and formulas. Thank you for watching this video.